it. Hey everybody. So today we are going to be adding a thermal camera to our NICS. So what we need for this project is we have a little Adafruit board here. This is the Adafruit FT232H. You can see that right here. This is a multi-protocol USB I2C, SPI, and GPIO chip. So we are just going to be using the I2C portion of this chip today. And we also have ourselves here a little Adafruit thermal imager. So this is the Adafruit, I believe this is the AMG8833. So it's a very low resolution thermal sensor. It's 8 by 8 pixels, which gives us 64 pixels. I already wired it up. This was from a past project. So we are just going to wire this thing up onto this board, and this is going to be connected via USB-C. And then we're going to hopefully add it to next to our sensor that is mounted above us, so we can have a thermal overlay for our wide version, or our wide shot. So the thing that we are not going to go over in this video is the soldering of the V-in, the ground, the SLC, and the SCL and the SDA. So we'll go over those later when we start soldering this, not soldering it up, but pinning it up on our interface board. So I'm going to just put this to the side for now. We'll come back to that a little bit later. So the first thing we actually need to do is we are going to need to solder these pin terminals onto this board. So what I'm going to do is I'm going to grab our engineer's friend here. I've got some extra hands, and representing my Radio Shack solder, which might be vintage now, I'm not quite sure. I don't know if Radio Shack is still selling solder. So first thing we're going to do is we are going to actually put this off to the side, because we're not using that solder. We're going to be using this high-tech silver bearing solder. You can see it right there. And so this is a diameter of 0.15. Oh, that's millimeters, and it is 1 ounce of this stuff. So we are going to take this, and let's just clean up a little bit there. Okay, so we got that, and we are going to turn on our soldering iron, and we're going to bring that over. So we got our soldering iron. Put this right there. Okay. And we're going to let that heat up. Currently, I believe I have this thing set to 372 degrees centigrade. That's where we are right now. So we're going to let that heat up. Almost there. So let's put this in our little hands here. So we got that. And we're going to take this first row, which I already broke off. So we put these right here. Okay. And I'm going to line this up so it's holding it nice and firm in there. The other way we could do this is actually putting it on a breadboard. And, you know, that actually might be the better way to do this. Yeah, we're going to change our approach here. We're going to take this, we're going to place it on a breadboard. So, got a breadboard here. And line this up. So look at that. We're going to apply some slight pressure so this thing is nice, and look at that. That's way better. That's a little more sturdy for us to do this solder job. It's a very simple solder job. So first thing we are going to do is we are going to, so under this we have, this is both brass tip cleaner with rosin flux reservoir. So that means that there is rosin at the bottom of this container. And clean the tip off by poking it in here a bit and getting some rosin on there so we can wet the tip. And look at this, nice burn right on there. Okay, so we're going to just solder up these pins. So nice project board. Okay, we got one pin on there, so that's nice and solid. And we got our second pin. It's 3 volt, is soldered up. Okay, and now what we are going to do is let's solder this side. Just all I'm doing is I'm securing pins in the end so that I can then put this on my engineer's helper, second set of hands over here, and actually solder it a little easier than having to worry about it on this breadboard. Alright, so now look at that. We got pins, we're on here. These now need to be soldered so they actually are connected. So I'm going to do that on our holder because I find that a little easier than trying to do it on that breadboard. Hello, whoever is watching. Thanks for tuning in today. Today we are putting together a SPI/I2C/GPIO board from Adafruit. This is the FT232H. It's got a little USB-C connector on one side, and we're going to be using that to hook up this thermal sensor and hopefully upgrading our camera up above us so we can have a thermal overlay. So please let me know if you have any questions. Happy to try and answer. I hope my volume on my microphone is good. Let me know if there's anything you want me to fix up. I'll try and do that. Today I'm also trying something new. I got headphones in and I'm listening to some music, so we're gonna see if I can multitask and also listen to music, because it was kind of boring without any music, and I don't want to get, in trouble for having anything that's copywritten while I'm doing work. So we're trying the headphones. Also trying some new settings on my audio, compressing it a little bit and also adding a noise gate, so hopefully it's a little clearer than it's been in the past. Okay, we're soldering up these pins. Honestly, for this project, if I stopped right now, we'd be good, because I only need the pins that are on this side of the board, because we have our GPIO connectors here. This is digital 7, 6, 5, and 4. This is SPI, this is MISO, this is MOSI, and this is SCK/SCL, ground and 5 volt. That would be enough to get this project actually working, but there's no reason that I shouldn't just continue soldering up this thing as we sit here. So this is these are the rest of the pins for our GPIO. That's 0, this is 1. And we got 2. If you want to listen along to what I'm listening to Modest Mouse. Just got that album playing in my headset. Okay, so we just got that one soldered, and that soldered, and that soldered. The fun part of this is going to be figuring out how this connects up to our Linux system, and then going into Python and scripting out something to preview our thermal camera. So today's going to be the first time I think we're really also diving into software. Make sure all these are soldered right. Make sure our 3-volt looks good. It does. Okay, let's clean off our soldering iron. I'm not going to need you for the rest of this project. So let's turn off our soldering iron. Okay, that's turned off. I'll let you cool off over there. Okay, and we can take this off of here. So we got that all soldered up. That looks nice. And let's put this assistant away because you've done your job. Good job. Thank you very much, little buddy. And you go over there. Okay, and we're dropping things. That's fine. All right, so now we got our board. We have our thermal imager, and we have our USB-C wire. So now what I'm going to do is I'm going to pull up our desktop. So let's do that. Let's open up a new Chrome, and we can use this as something we are going to broadcast. We're just going to broadcast this one little window. So I'm shrinking up my interface here. Okay, so here we're going to add a screen capture. And you know, we're not going to do a screen capture. We're actually going to do a window capture. So set up a window capture. Okay. So now we are capturing this. Okay, so we're just going to move these things over here, just so they are viewable. And probably also going to put a little window in here that is showing our what we're coding. But we're going to just leave this here for now, and let's see how we can hook this thing up. Let's see what we got to do. So the first thing we are going to do is we are going to Google this little board. So this is the AMG 8833. So AMG 8833. Adafruit. Look at that. Here we go. So look at this. This is what they're doing. Oh, look at that. We have some weird colors going on here. So we gotta invert. Okay. So we got our colors now properly. Okay. So let's see what they want us to do here. Technical details, learn. Let's see what our learn is. So we just want to get this thing working nice and quickly. Okay. So it says they've done all the hard work here. So let's see what they really got. So this is the sensor we're using. Actually, we are using a knockoff of that. We're just using a board that is similar. Ours is not the Adafruit version. Ours is just a cheaper version of that board. So let's see. Where do we plug this thing in? Okay. Okay, so SCL is the I2C clock pin. Connector microcontroller's I2C clock line. There is a 10K pull-up on this pin, and it is level shifted so you can use 3 or 5 volts. Okay, that's good. And the SDA is the I2C data pin, which is connected to your microcontroller's data line. There is also a 10 kilohertz 10K resistor pull up on there. And then we have our interrupt. This is a logic so you can detect when something moves or changes. We're not going to be using that. Okay, So let's take a look at our Adafruit board here. And we have our SCK, or SCL, which should be as our clock. I don't see, SDA. Okay, so SDA is also the MISO pin. We're gonna look at this online and we're gonna check it out because it looks like right now. So we have a 5-volt out right there. We have a ground there. We have our clock, and then one of these is our data in. I'm gonna guess it's this one that's closest to our clock. But what's really nice is Adafruit has these boards really well documented. So we're gonna bring that up in another tab here. So let's open this up. This is the FT232H general purpose breakout board and everything. Okay, so here we go. That looks like what we got. Yeah, that looks just like it. Okay, so let's go to technical details. Okay, let's see what you got to say with the learn. Okay, so there. Okay, so this looks like it's going to be giving me the information that I want. Give me some pinouts here. So, okay, assembly and wiring. Okay. Wiring. Okay, so here we go. Here's some interesting information here. Our D0 through D7. These are our UART and GPIO pins. C0 through C9. These are also some GPIO pins. Next thing I want to know is where is our SDA. So we're gonna keep looking in through this document. I think I must have missed it. Let's go back. Hello, viewer. Thanks for tuning in. Got any questions, please let me know. I'm not seeing where it says my SDA pin is. That's fun. These pins. Okay, so we're gonna just keep going through these documents. This is COM for Windows, serial usage. Nope, don't care about serial usage. What I really want is I want to know where this is how we're gonna be connecting this up on Linux. That's good, we're gonna need that. We're not dealing with UART, that's fine. What we're gonna do is we're just gonna type this in. We're gonna type that in and we're gonna type in I2C. Okay, here we go. We have an example project here. There's an I2C device using this breakout board. It's good. Okay, so wiring, here we go. Okay, so I2C is D1 and D2. Right, that looks understandable there. Okay, so we're jumping ahead of ourselves here. We're not going to do an SPI. That's fine. We are going to do this thing with this. So let's see. So this is saying, okay, to summarize, for using I2C, you need to set up your hardware as follows. Connect D1 and D2 together with a jumper wire. This combined connection is the I2C SDA data line. So that must be these two right here. So it must have an input-output. That makes sense. All right. So add a 2.7 kilo ohm resistor from the I2C data line, pin 1 goes above to the 5 volt. Add, this is D, okay. You know, we're not going to do that because we don't have to do that. So what we are going to do is we do need a wire that's going to connect those two together. And you know, we're going to do it on a breadboard because that makes this easiest. So we're going to just push this into our breadboard. Got our little USB connector on the outside. Let's make sure we can plug this in. So, okay. Okay, let's see if this does this slide right in. That's too tight. Okay, so let's take this, give it a little bit of wiggle room. We're still connected up. Okay, so that is connected. We're going to plug this into the USB on our computer. Hopefully we don't kill anything. So here goes nothing. And I don't know if we have power or not, so there should be a little light on this thing. Yep, there's a little green light in here. You can see it right there. That means it is on, so that's good. Let's actually push this down a little bit. So we're gonna make this as snug as we can make it. Okay, so that's nice and snug. And unfortunately, let's see, does this want to stay? Might need some type of weight to hold this down so it doesn't move. Let's see. Do I have any type of weight that I can use? Not really. All this stuff and no paperweights. Oh, you know what? I do have weights. Let me go grab my standard metric weights. So give me 1 second. Always good to have some standard metric weights on you. Okay, so take our, yeah, fuck it, 500 grams. There's 500 grams. You right there. All right, 500 grams. Realizing now it is a little difficult to broadcast and listen to music, so I'm going to stop that. Get the Spotify out of my ears. Okay, so there we go. We got that. You know, and I also might go grab a extra thermal chip that is not wired up like that already. That might make it a little bit easier for this project. So give me 1 second to grab that second raw thermal chip. Okay, so I got my raw thermal chip here. There we go. So here we go. We got our thermal chip. I'll take that out of here. And we are going to need to solder this thing up. So, okay, here is our unassembled thermal chip. We don't have it soldered in with some wires. So we're going to just take this one, disregard it for now. Put this back in this bag. We'll use you later on a second project. Go put you back in my my store. I'll be right back. One thing that I like to do is make sure that I keep everything nice and organized while I do these projects. Dear friend Simon taught me that. He's no longer with us, but he was an amazing fabricator. And Simon taught me that you gotta keep your workbench in order, because you don't want any miscellaneous pieces of metal or dirt getting into your project and causing gremlins. Alright, so we have our raw chip here. This has got our inputs on it. Let's see if I can maybe get this a little closer to it. No, we're not going to be able to see it on the camera. But we have VN down here. We have ground. We have SCL, SCA, INT, and ADD. I don't know what oh, that's ADO. So that's, I assume it's analog out of some sort. And interrupt. Okay. So what I'm going to do is I'm going to turn this soldering iron back on, which I thought we were going to be done with, but I guess we are not. So we've got our trusty soldering iron back. Pardon me for the meantime, I'm going to turn off that window capture. Okay. And, you know, we're going to solder these pins down like so we can wire this up like this, and we'll be able to get some nice tests done. So I'm gonna take this. This is not gonna be the prettiest example, but it'll work. So, you know what I'm gonna do? I'm actually gonna grab some extra pins that I have here. We're gonna try and set this up so it stands by itself. No. Is it gonna work? Can I do this? It's gonna. Look at that. Okay, that worked. That was fun. Okay, so now what we're gonna do, we got our soldering iron all heated up. Oh, and we're losing things. Oh, we lost the lens cap. That's fine. We don't need that lens cap. That's for an old camera anyway. Okay. So, got that, got our solder. Okay, got some rosin on that. And let's just start with our VN all the way right here. Sorry it's not center frame, but you know, do what you can. Alright, so that one's in. Ow! Shouldn't touch that. Touched it. That was hot. It's a mistake you make, but it's life. Alright, so what I'm going to do is I want to actually even this out a little bit. So I'm going to continue to... Oh, sorry, out of frame. So I'm going to loosen this up. Let's get some rosin on here because it'll make it a little easier to get this thing to melt back. Okay, that's nice and it's pretty perpendicular for our usage. Okay, so now we're just gonna solder the rest of these pins on here. Just soldering nice and slowly. Okay, that one is connected. That's connected. Connected. And the last one we are getting is our ground. So our ground is connected. Okay, so got all those connected. Somebody's asking what I'm making. So what we're making today is we are going to be adding a thermal camera, a thermal imager, to our overhead camera so we can keep an eye on the components that we are building in the dimension of heat, the thermal dimension. So what I'm doing is I am working with some pre-built parts here from Adafruit. we have an Adafruit FT232. This is our SPI and I2C and GPIO interface board. And we have a AMG 8833 thermal board. This is an 8 pixel by 8 pixel thermal imager. And what we are doing is we are putting together just a quick project board so we can visualize thermal coming out of this little camera. So, next thing we need is we need some jumper cables because we need to wire this thing up. So here we go. Got our testing cables. Huzzah, testing cables. All right, so testing cables. First thing we are going to do is we need to wire up a cable. Actually, what we need to do is it says that we need to join these two pins together. So this is the MISO and the MOSI, and together these make the SDA channel. So we're going to take a blue cable and we are going to put that in here. Okay. And let's take, do we have, what else is similar in length? I guess this brown one is similar in length. And we are going to put that into there. Okay, so now both these cables are going to this row. So this is row, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So these are all going to row 16. And what we're going to do at row 16 is we are going to jump those over to our SDA port right here, our SDA. It's on row 20. So let's see, do we have something that can go a few of those? That looks a little too long. What do we have? Does this orange one do it? Still too long. Maybe one of these little brown guys. Yeah, look at that. So we're going to try not to do this as clean as possible, just because we can. So we got that is jumping from row 16 to row 20, which is our SDA. And now we need a connector to go from SCL to our SCL. So row 5 to row 21, row lucky 21. It might be one of these gray dudes. Let's see if gray is our lucky color. That's a little too long. I think that's going to be too long as well. So we are going to need to bend it. And so here we go. So let's take gray. You are going to go up, and it looks like I also wired this wrong already. So we are going to get rid of this wire. This blue wire is not quite the one I wanted. That blue one didn't go to the MISO. It only went to the SPICS port. So that wouldn't have been good. Oh, look at that. I found my lens cap that went on the ground. Found one under my desk. Look at that lens cap. Great. I'm going to put that over here. That's safe for now. Okay. So let's grab another one of these brown cables. And you're going to go right in there. And you're going to stretch to there. And come on, baby. You can do it for Papa. There we go. Alright, so that's in there. Okay, so that worked. And now we are going to take this cable and we're going to gingerly get you from row 5, and you are going to go into this row 21. I guess your column 21. So there we go. those are nice and wired. And oh, you're getting a nice view of the top of my head. That's great. Okay, so the next thing we are going to do is we need to hook up the ground and we need to hook up our voltage input. So on this board, we can use both 5 volts and 3 volts. And just for the sake of not frying our board, let's just use 3 volts. And also, we're gonna plug in our ground. So I think, let's see, are these the same? No, these don't look like they're the same length. Yeah, that's a little bit longer. But I really do like having my hot wire be orange and my ground being gray. So we're gonna see if these wire up, and it looks like our 4th row here, or our 4th column, is our ground. So we're gonna plug you right into there. Okay, and we're gonna snake you over to our ground pin. Okay, and now what we're gonna do is we're gonna take our hot, go at 3 volts, and all this stuff could be done with a Raspberry Pi, but you know, I really just want this camera to be connected to my computer directly. I don't want it to go through a 3rd system. Okay, so that's all wired up. So now the question, is it going to work? What's it going to do? What is all this stuff? Now that we have these wires in place, let's put this out of sight, out of mind. Let's bring back up our window, and let's go back to our software here. Let's see, we got our assembly. Yep. This is everything we did already, but using ours, not theirs. Here we go, Arduino wiring and testing. Let's see. Are they doing it via the I2C? They are. You can see they have it very similarly wired up like we do, but they're doing it with a Arduino. Look at this. So we don't want to do it with Arduino. We want to do it with well, we want to do it with Python. So this is not how we want to do this, because this is just directly outputting data from an Arduino board. Here we go. So Python and CircuitPy. Okay, so they are doing it with the same I2C. Python wiring, okay. And here we go. Let's see how they're going to do this. So it says what we need to do is we need to install Adafruit CircuitPython AMG88XX. So we're going to open up our Python shell. Let's move this a little bit further up. Yeah, and let's open up our IDE for editing Python. I like to use PyCharm. So I'm going to open up PyCharm, and once I open up PyCharm, I'm going to create a new window on our broadcast so you can see what I'm coding. And luckily, most of what we're doing is going to be just right out of this sample code. We don't really have to do anything. That's really nice. So PyCharm is opening up. Okay, so PyCharm has opened. I'm going to shrink it down, make it fit in this window right here. Oh, got big again. Didn't want that. Oh, pardon me. Drinking bubbly water gave me a little bit of gas. Okay. So we're gonna make a new project, and I will show you that screen in a second. Actually, you know what? That's fine. I can just show you my PyCharm. So I'm gonna make a new video capture. I don't want new video capture. I want new window capture is what I want. Window capture, and here we go. Okay, so you can see PyCharm. So I think maybe what I'll have to do here, yeah, we're gonna change the dimensions of PyCharm. Let's see. Let's take this and we're gonna shrink it down like that. Okay. And we're gonna keep shrinking you down until you're, there we go. Okay. Let's reorganize that on this desktop. Maybe see what we're doing here. Okay, and let's take this window capture. We're gonna move this a little bit. What we're gonna do is we're gonna make that more narrow. Okay, and we can probably move this down just a little bit so we're in view, and then eventually, once we have some stuff working, we're going to put our little preview window in this corner. So that makes sense. Could you also use this to monitor people's temperature? Yes, you could. This is the same sensor that they're using in a lot of the off-the-shelf like thermal point them at somebody and see if they have a fever or not systems. Okay, so this also needs to have our red and blue swapped. Oh, it's freaking out. I don't know why it's freaking out like that. Okay, well, stop freaking out. Huh. That was weird. I don't know why it's doing that, but I guess our Python window is gonna be the wrong color. Okay. And also, why are we streaming and restreaming our Twitch window? That's not right. That's what we should be streaming. Okay, we're getting there. We're slowly getting there. Okay, so here we go. We're gonna make a new project in PyCharm. So first, we're gonna call this thermal. We're gonna call this PyCharm thermal cam. Okay, there we go. And we're gonna do it in this window so we don't break everything. Okay, so this is building. There we go. Okay. So first and foremost, we're gonna go to our terminal, and we need to. First thing I want to do is I want to see what version of Python we are using. So let's see what Python it does by default. Python. All right, so that we're already using 3.6.9. It was built a bit ago, but you know that's fine for what we're doing. So first thing we're going to do is we're going to sudo pip 3 install Adafruit CIRCUIT circuit Python -AMG88XX. Okay, so that's downloading and installing. What's the name of the sensor? The sensor is the AMG8833. Should be about $45 if you find it on Amazon. Maybe a little cheaper. Altogether, this project is going to cost somewhere around $65. But hey, $65 is not bad for a thermal camera you can add to your computer. All right, so look at this. This is our preloaded code here. We're gonna see if these libraries exist already on on our system. So we are going to add a new Python file, and we're going to just call this camera test.py. Pardon me again. Okay, so camera test.py, import time. That one that's a no-brainer. Import BUSIO. Yeah, I don't think we have that. I don't think we have import board. Yeah, we don't have that library. Import Adafruit AMG 88XX. Yeah, we do. I think we have that one. I think we just installed that. You know what? I think we just installed that library not to our virtual machine. I think we're compiling with a standard compiler here. So let's see. What is the environment? Oh, it's using the virtual one. Okay, so what you can't see is I'm changing over the compiler to the system-wide compiler for this project, because the libraries that we just downloaded were for that. I'm going to leave you to the dentist. Too bad. Was interesting. Greetings from Belgium. Well, enjoy the dentist, and this will be recorded so you can check it out later when you get back from getting your teeth looked at. Thanks for watching. Okay, so we are going to run this test. Yeah, so it's freaking out. So I want to change. Okay, so what we're going to do is we're going to edit the configs, and we are going to set this up to use this library to compile with. And is it finding these libraries or no? Okay, so it looks like it's missing those libraries. So let's figure this out. So we're going to go here. You can't see this, so we're going to our project interpreter settings on this computer. And we are going to add this one again by hand. So this is the Adafruit. CircuitPy. So what you can't see is I'm adding these packages to our system. Did it finish? So I guess doing something. Adafruit was successfully added. Okay, so now let's see if. Okay, so now those libraries are resolved. And I think I might actually have to take this and change it back to our virtual environment. Yep, so here's our project default. We're going back to our virtual Python environment. Okay, so now what we're going to do is we are going to add, so I2C equals busio.i2c, spelled busio wrong, so there's busio. Okay, busio I2C, and this is board.scl and board.sda, and then we have our AMG, and this is that's our sensor. This is Adafruit. Okay, and we are getting this from I2C. Okay, so now we're going to see what happens. Okay, so board format, and we should have the board identified. So I feel like board not supported. Okay, so what I want to do here, I guess I can do it in this terminal. Let's see if this thing is showing up on USB. So we're gonna ls our /dev device, or our /dev folder. Okay, and you know we're gonna do this with asterisk.tty. TTY that. Okay, so we are seeing it in this TTY USB. I believe this is that device. So we're going to ls USB. What do we have here? Yeah, so this is it. Yeah, the FT232H. So the question is, I wonder if we have I2C. Why did I2C scan pop up? I don't even know what that is. We're gonna run it. Oh, look at that, we did something. So available devices are FTDI 232H. Yeah, okay, so that is, this board is working, and we're finding it. So now what we need to do is we need to figure out why we're not seeing it. So let's go back here. Let's look at this example here. Yeah, so we should import this. So we're going to go into our settings, which for some reason is not screencasting, but that's fine. And we are going to add the Adafruit, and we are looking for the this is the FT. So Adafruit, CircuitPy. And what you can't see that I'm doing, I'm scrolling through their libraries here, and we are looking for the FT232H. So F3, I don't see it under CircuitPy. Adafruit, let's see, Adafruit, do we have it here? Well, there's nothing in the Fs on this. It's Adafruit Thermal. Nope, that's for thermal printing. Okay, we are still looking. Okay, well, you know what? Let's just let's read documentation. Okay. So this, oh, we need the Adafruit GPIO. That is the library we're looking for. Okay. Import settings. No, we don't want import settings. We want to open settings, and we are in our project interpreter, and we are going to add Adafruit GPIO. Okay. Why do I feel like that's not an official Adafruit thing library? I don't want to install that because that is not official. Probably should read this document a little better, but oh, there we go. It's right here. Library to provide a cross-platform GPIO interface on the Raspberry Pi and the Beagle Black using the Raspberry GPIO and the Adafruit BBIO libraries. Okay, and I think what we're trying to do here is the Raspberry BBIO. Okay, so we're adding this. That's downloading. It's successful. Okay, so for now, what we're going to do is we're going to comment that out, and we're going to just try this. So this is going to be, don't want that comment. Okay, so we're going to import Adafruit GPIO dot, there we go, as FT232H. Temporary disable the, okay, we don't want to do that. So we're actually going to do here is we're going to do this. We're going to do I2C, and we're going to type in AMG88XX. Because there's no reason to reinvent the wheel. The thing that you find in technology development is just find example code. So what is our top example here? We don't have that. Maybe let's type in 33. Thermal camera. That is not giving me the info I want, but it's interesting. Okay, let's go back here. And I don't really want to have to do all this work, but that's fine. So for some reason, okay, so the board isn't being defined in this, because I don't even know what bus.io, how this library works. So you know what we're gonna do? Let's Google how this works. Let's do Adafruit bus.io. Oh, is this trying to do it with an Arduino? Is that why? Okay, so Adafruit bus.io library. This is a helper library to abstract away I2C and SPI transactions and registers. Adafruit invests time and resources providing this open source code. Please support Adafruit. Okay, so Adafruit. Let's see examples, and we want SPI read write. Yeah, just as I thought. This looks like it is for an Arduino. It is. Okay, so we jumped too far ahead. What this is doing is this is replacing this board with a basic Arduino board and connecting it via the serial port on that Arduino. So that means that this Python and okay, so this is all the wrong things. Okay, so let's see. There's got to be an example here of just using straight Python and not having to use our I2C on a Arduino. Yeah, this is doing it from Arduino. Let's just see what this is. Yeah, Python docs. Okay, so we are going to look back at this document here, and this should be using, okay, so usage, to make this device code work with the FT232H, you need to make a few small changes to the code. First, you'll need to include the FT232H module, enable the F232H, and create an F232H device by adding the start of this code. Okay, so we're going to do this. So let's temporarily, let's just trust that they know what they're doing, and we're going to temp disable FTDI serial drivers to use the FT232H device. So that's going to give us this, so F32H. Use F32H, okay, and we are going to create an instance for it. So let's create the FT232H dev inst, and that is being done by FT232H equals FT322H dot. Okay, so if this runs, it's not really going to do anything. Okay, we are missing, there's no module called ftdi1. Okay. Where is this error coming from? This error is coming from line 9. So line 9 here, there is no FTDI module. Great. So much fun. Why? What are your problems here? What library do we need to install? So we're going to go back and we're going to look at these settings from our interpreter. And let's see what other Adafruit library we need, because we need one apparently for FTDI. So, Adafruit, and we are looking for one that is FTDI. Adafruit. What we also just added was the Adafruit AMG88XX, so we're not dealing with the CircuitPy. We already have Adafruit Pure IO installed. We don't need Adafruit BeagleBone IO channel. Just gonna slowly click through all of these different modules here. What I did was I opened up our available packages and just typed in Adafruit, and we're going to see what the different modules are here. Unfortunately, you can't see that on the screen, but I'm going to be reading them to you. Well, as many as it makes sense to read. Let's see, what's Adafruit TMP? That's a non-contact temperature sensor. We're going to just, okay, here we go. We have libraries for Python and BeagleBone, so that's the Adafruit libraries. That's installing. That was installed successfully. I installed another library called Adafruit IO. Alright, so I think that these are all the official Adafruit ones that I need to install. I got those installed now. Okay, so let's try and run this again and see if. Okay, we didn't solve this, so that's we're now going to have to, oh, I think this may have been, no, that's not my problem. So we need to find this library. So we're going to FTDI1. Okay, so let's just Google this. We're going to okay, so this is not an Adafruit driver. That is the thing. So we are going to try this again. Okay, so the library we need here is the ctypes FTDI1. So we are importing that package now. Package has been installed. And let's see if we can run this now. Oh, we have some new errors. That's fun. So what are our new errors? Our new errors are unidentified attribute ftd int. Well, this is so much fun having issues here left and right. So actually, what I'm going to do here is I'm actually going to go back here and we're going to try this. So this is the installing usage. I wonder if this has some examples of how to use this without using CircuitPy. Nope. Alright, so I don't know why this is freaking out when we are trying to initialize this with just this raw code here. Okay, so what is our traceback? Line 9, which is this. Okay. Import ftdi1 as ftdi from import ftdi. Okay, I wonder if we're just missing that in our system. So let's try. Let's look. Sudo apt search ftdi. Oh, well, we don't have, it looks like we don't have the development library in here. So that might be a problem. Although I don't know which one it is. So that's fun too. So let's see if this just solves it. I'm going to install this package. This package is Python 3 ftdi1. So let's just sudo apt install. And let's see if it picks up the dev library as a requirement. It does. Okay, so it's gonna install this as well. That's fine. So let's do that. This might be a way to fix our problem. That was my suspicion, was we didn't have the library installed. All right, look at that. It's doing its thing. All right, so that's installed now. Click play. Oh, okay. So expected to be run by root user. Try using sudo. All right, so we are making progress. That's fine. So in here, we're just going to run this as sudo. So sudo, and then also what we're going to do is we're going to add a shebang up top. So let's make this so it's executable. We don't have to really worry about writing Python in front of it. So we have shebang slash user slash bin slash Python 3. Let's see if that works, because I'm not sure if it's in user bin or if it's in user sbin. So user bin slash Python 3. Look at that, it worked fine. Okay, so let's exit that. But that's gonna not use our local compiler. So where is that located? Okay, so our local Python is located relative to it in v environment bin Python. So let's do that instead. Let's see if that actually does the job. So instead of user bin, we're gonna do // v env /bin /python. I don't know. I've never done a shebang with that before. So let's save this, and then what we need to do is we also need to change mod this file so it's executable. I do the lazy man's change mod where I change it to 777. Not the best practice, but whatever. Oh, we're in Python still. That's not gonna work. So chmod 777 camera. Okay, great. So now it's executable, and let's see what happens if we. Okay, so bad interpreter on no such file or directory. So I think we might have to give this a global path. So let's just give this a global path to this. Okay, so Python copy path. We're going to paste this in here. Okay, and it said we need to sudo this in order for it to work. Yeah, so let's add sudo to the start of this. Okay. So now, what are we getting? We're getting in line 188. Yeah. Oh man, this is just a mess. Why are you such a mess? Takes 2 position arguments, but 3 were given. And man, this isn't even code that I've written. What are you doing? Why are you such a pain in my butt? Did I not put something in here? No, it's not what I missed. Oh, everybody, welcome to the joys of code. This is how it goes. So let's take a look at the file that you're pissed off by. All right, let's see if you have some context here. Okay, so disable the FTD driver for the current platform. This is necessary because it will conflict. Okay, no, you can enable. Okay. So here's what we're going to do. We're going to unplug and plug it back in because that sometimes fixes things. So unplugged, plug back in. Well, that didn't fix it. But let me make sure that I have this code here correct. You know what we're going to do? Let's A/B test this. All right, so that did something different. The thing is, I don't know what any of these drivers are really doing because there's not a lot of documentation here. I really wish this would just work. Maybe what I should do is I should plug it into an Arduino and load up CircuitPy onto that Arduino and go with that approach. That'd also be cheaper than using my my little test board here. It's been a while. It's been about I've been broadcasting for about an hour and 15 minutes. I really want a snack. It's been one of those nights. So let's see. Let's look at our stock of Arduino boards here. We got this little guy. Very similar in size. Do we have I2C on here? Man, I don't even know if these Arduino boards have I2C on them. I don't want to do that. I'm not gonna do that. Okay. Let's see. We're gonna pile. We're gonna get through this. So let's re-enable that line of code, and we're gonna have to Google things. Okay. So can't be the first person to be dealing with this problem. So what we're going to do is we're going to take this line, we're going to copy it, and we're going to go over to our trusty Google and paste this shit right in. Okay. Look at this. Looks like we have a taker. So I met this error since I installed libftdi. Okay. Did you manage to solve it? Well, the only current way to make it work is to roll back driver. Thanks. So they're saying that the Python 3 Blinka library is going to fix it. So we're going to try it. Let's see what happens. Let's install Blinka. Okay, so we're installing Blinka. Says Adafruit. And Blinka. Use the library that it wants us to install. It's Adafruit-Blinka. Why do I not see Adafruit-Blinka? Oh. Adafruit-Blinka is already installed on my computer. Okay, so how are we going to use Adafruit-Blinka? So from testing import test module. That is not helpful. Let's see if we got an example in here. So Adafruit. Alright, so we're going to search in here for... Why can't I search in here? Let me search inside your folder. Come on, people. Search. FT... Okay, this is fine. Okay, so FT232H inside of this repository. Yeah. Okay. So it looks like my controller pins. Alright, so it looks like the way to do this is we're going to type in this. We're going to see what happens. Well, we're going to go here. Let's go here. Okay, this is doing a lot of things. So, you know, let's go back. We're going to open this in a second window. let's also see what this one does. What do you do? And all right, so let's see. These both look like fun files to play with. Okay, so this is defining our pins. All right, so you totally are an assembly type file. And what are you going to do? What do you do? So you are class I2C class for the FT232H. So what is this file doing? So what you're doing, you're just a class. Okay, so you know what we're gonna do? We're gonna search the internet. So let's do this. So let's do this is Adafruit Blinka, Adafruit _ Blinka. Blinka. And let's do FT32H. Okay. What do we got here? Look at all these boards. All right, so here we go. Linux. Looks like it wants us to install this, so let's do that just in case. Let's make sure that you're installed. Okay, that was already installed. Wants us to add a udev. Okay, well, okay, so this is what would solve our problem here with not having to use sudo. This is nice. So let's do that. So what we're going to do is we are going to sudo, and we are going to sudo nano /etc/udev rules rules. We're going to name it 11-ftdi.rules. We're going to just paste in what we had there. We're going to write it. We're going to exit. Okay. So what this did was we needed to basically add some rules to our system. So every time we plug in this device, it lets us use it without having to use sudo. So what we're going to do is we're going to unplug it. Okay. We're going to plug it back in. So now, assuming that did its job, if we ran this with this code that breaks, it should tell us it runs. Oh, it didn't work. Well, that's fun. Does our udev rule, does that exist? Let's just cat that file. We're going to cat the file from before. It exists. I think we have to reload our udev rules. I don't remember how to do that. Reload udev rules without rebooting. To do that, we need to type in this. Oh, I need to be root for that. That's fine. Okay. So now, why have you forsaken me? Man, I don't want to I don't want to reboot, I don't want to do all these things. That's fine. I'm just going to keep going, and we'll just have to type sudo in our command line. What is this? Set environment variable. We need to manually signal to Blinka that we have the FT232H attached. I still think we're looking at the wrong thing. Why do I feel like we're doing the wrong thing? CircuitPython libraries on any computer with the FT232H. That sure as hell sounds right, but I don't like having to set an environment variable. Alright, fuck it. We're doing it. We're setting an environment variable. You've been setted, and we can check it by typing in that BLINKA FT 2H. Oh. There we go. Got my syntax there for a second. That's fine. Didn't delete anything. I was gonna take a snack break, but it doesn't look like that's happening. Okay, post install checks. Alright, so post install check, it wants us to run this code. So let's just I guess we're gonna do that in this terminal. Actually, you know what? We're gonna open up a new terminal. Can I open a second terminal in here? Does that work? Yeah, look at that. Second terminal. Okay, look at this. Okay, so we have this. So we're gonna Python 3 from right there. Yeah. Okay. That worked. Look at that. That's promising. Ooh. Okay. So it detected it. It just doesn't like whatever these things are. Let's see if we can import board. Okay, so it freaked out on that one, so that's fine. Oh. Why did we... Okay, so what we're gonna do is we're gonna try this. Let's I feel like we're getting close. I feel like we're getting there. I feel like this garbage here is not helping us. I feel like that's boning us. I did like what this was doing, so let's try this. Let's see what happens if we do this. So we're gonna import these two things. Let's just copy that code and we're gonna bring that there. Whoa, okay. We're gonna just run this, see what happens. Board not supported. Alright, so why is the board not supported? Let's see what this says. So it says, this could mean that you did not set the environment variable, or you do not have the latest Python libraries, or it's not plugged in. And is it breaking on board? Is it breaking on that line? Yeah, it's breaking on line 5. All right, so let's see what happens if. So let's make sure our environment variable is set here again. I think we've done that in this one. So environment variable there is set. And what happens if we just run camera test? Whoa, okay, that did something different. So that looks like it ran. So available interfaces are that. So what we're going to do is we're going to just duplicate that line, turn off that line, and let's open URI or open from URL ftdi 232 h-1 dash. What happens if we run this? Module object is not callable. Okay, well, we got further. It means that line 13 is pissed off. Okay, so we are going to, let's do this. So we are going to import sub process. First thing we're going to do in this is we're going to, let's change sub process as sp. So sp dot call. We're going to set our environment variable here. Shouldn't have to do, but we're going to, because it looks like it's pissed off by that. Export Blinka ft232h equals 1. Oh, so looks like we have to do that above here. So let's do that first. Piss that off. See if that works. No such file or directory. Man, you should just work. Let's see. No such file directory as export. Am I using sp call wrong? Is that what's happening? Am I doing this the wrong way? so it looks like there's an easier way to do this. So let's import OS, and we are going to do this. All right, everybody. Oh, just got a message. All right, so we are going to sign off for now. I'll be back in a little bit to pick up where we left off. But yeah, we're getting there. Thanks for checking in. Be back soon.